Suppose that you want to write a statement that uses these grouping sets. You want to group by region, salesperson, and company, region and salesperson, region, and then the all records option. The important thing about this pattern is to notice that each subsequent group drops the last field from the previous set. So this is a very common pattern when you're working with certain types of hierarchical data. So here for reference are those grouping sets that I want to create. And here's a query that does that without using the roll-up operator. So I have group by grouping sets, region, salesperson, company, region, salesperson, region, following that pattern of dropping the third, dropping company, then dropping salesperson, and then dropping region. All right, and if I select that statement and execute it, whoops, it would help to change the database, and execute it again. Okay, so as you can see, we get 15 rows, and they're grouped in the different grouping sets. So here's all the fields, 2 fields, all the fields again, 2 fields, go down further, here's just by region, and so forth. All right, so same sort of usual use of grouping sets. And here's a statement that uses the roll-up operator instead of grouping sets. So instead of defining all of these individual grouping sets and meticulously putting in parentheses and commas and getting it all right, which could be quite a chore if you have a lot of different columns, a lot of different sets that you want to group by, all I need to do is use the roll-up operator. Notice I'm not using grouping sets there. So it's a roll-up operator, and I specify those 3 fields. And then SQL Server takes that and then generates that pattern. And so I can execute this statement, and we get the exact same results, 15 rows. And if you compare the two, you'll find that they have all the exact same rows, same results between these 2 statements. So rollup is just a shortcut to writing. Instead of writing this, you can write just that. And the other thing is, because rollup is just a shortcut, SQL Server is actually executing this type of statement. So the execution plans for this statement up here and the one that uses rollup are identical. So go ahead and show that. I'll select both statements and look at the estimated execution plan. As you can see, this is the first query is 50%. If I scroll down, it's a little bit annoying with all that flashing as I hover over different items. And there's the second query that uses rollup, and it uses the exact same execution plan, same steps, and the cost is identical at 50%. So anytime your grouping sets follow this pattern of dropping the last field, then rollup can save you some typing. You're not going to get a more efficient query, but your code is going to be simpler. The cube operator is conceptually similar to rollup, but produces a different pattern of grouping sets. A cube generates all possible grouping sets from the list of fields in all unique combinations, including the all records grouping set. For example, say you want all possible combinations of the region, salesperson, and company fields. And so there's the complete list of all possible combinations of those. And I'm listing them in no particular order. So you could certainly try to write your grouping set query and specify every one of these combinations. And that's hard enough with 3 fields, but what if you had 20? Okay, so it's much easier with the cube operator. Here's how you could write a select statement that generates all of those grouping set results. So you meticulously put in all possible combinations of those 3 fields. Or you could use the cube operator, which simplifies it into just that clause right there. So once again, it's group by cube, region, salesperson, and company. And then it generates all possible grouping sets, 2 to the n combinations altogether, and then executes the query and returns the results. So I'm going to select both these statements and execute them. And there you have the results. As you can see, there's a total of 78 rows returned by the two queries, 39 for the first statement, and 39 for the second, because the results are identical. So using that 2 to the n formula, there's 3 different columns, so it's 2 to the third, which results in 8 grouping sets. And the cube, once again, is just a syntactical shortcut. So the execution plan for both these queries is once again identical. But one important thing about this, don't equate the number of grouping sets with the number of rows that the select statement is going to return. I have 8 grouping sets, and each of the queries returns 39 rows. You can see that right there. The number of grouping sets depends on the number of fields, while the number of rows depends on the number of unique combinations of fields in the data. It's a characteristic of the data. So that's why we ended up with 39 rows for the total of all of those grouping sets. As you examine the results of queries that use grouping sets, particularly as you start including more grouping sets or use more columns with the rollup and cube operators, it can be confusing to figure out which grouping set a row belongs to. It's not so hard with just 3 fields, but with 20 it can be a nightmare. So, T-SQL includes a grouping ID function that returns a numeric identifier of grouping set membership. There's really no innate meaning to the value returned, except that the numbers are sequential values for all grouping sets. But with it, you can sort the results and make sense of set membership. The grouping ID function takes as arguments the same set of fields that you use with the rollup or cube operator in the query. If you specify anything other than those fields, in fact, you'll get an error. Here's an example of using grouping ID with rollup. So I'm using rollup here within the group by clause, and then the grouping ID function there in order to return a grouping ID column with the results. And again, the grouping ID value is going to identify which grouping set that particular row of data belongs to. So I'll execute this query. And there you have the results. Here's the grouping ID. And so you can see that this set is the 0th group. So this is obviously grouping by region, salesperson, and company. And then you have set number 1, which is the region and salesperson. And so now you can easily scan through this, sort on the grouping ID, whatever you want to do, in order to collect the results for different grouping sets together. And as you scroll down the results, you can see that we have 0 and 1 and 3 and 7. Well, okay, so the numbers aren't sequential. Why is that? Well, the reason here is because this statement uses the rollup operator. Scroll down there again, so the rollup. Remember that rollup doesn't generate all possible combinations of grouping sets for, in this case, the 3 columns that I specify. It's only a subset of them. And so that accounts for the missing ID values there, because I don't have all possible grouping sets for that combination of columns. So then I have another example here that uses a cube. So that's the only difference in this statement. So I'll select all that and execute that. And notice that we once again get the 39 rows that we saw from previous examples. And now I have grouping IDs, 0, 4, 6, 4, 6, 0, so forth. But now, if you scroll through all of these, you'll find that all of the numbers from 0 to 7 inclusive are there. So there's 1, 2, 3, 4 was up there, 5 was right there, 6, and 7. Okay? And I don't think I said 0, but 0 is there too. And again, that's because the cube operator generates all possible grouping sets. And once again, I can sort by grouping ID whatever I want to do in order to process these results. Now, what's cool about grouping ID is that you're not limited to using it with grouping sets that use rollup and cube operators. You can use them with regular grouping sets as well. And here's an example of that. So in this case, I'm grouping by grouping sets and specifying all these different combinations and using that grouping ID. So I'll execute that statement. As you can see, I once again get the 39 rows and I have the grouping ID because this is in fact the identical select statement as the previous query that used the cube operator. But this time, I'm just using it with a regular grouping set and including all possible grouping sets. And SQL Server also provides a grouping function that you can use to test whether a row is a member of a particular grouping set. It returns a true or false value.